Most of the mole concept calculations will involve concentration. And this is a very typical example of what the calculation will look like. Okay, so if I have 25 cm cube NaOH requires complete neutralization of 20 cm cube, 0.5 mole per dm cube sulfuric acid. What is the concentration? Okay, so question is asking me NaOH concentration. Okay, to find the NaOH concentration, you need to have the mole first. Okay, so how do I get the mole? So dissecting the question, right, this is the important part. Your reagent, sulfuric acid, you have the volume, you have the concentration. Okay, so from volume and concentration over here, right, I can find the mole. How do I find the mole? Take the concentration, which is mole per dm cube. I times the volume in dm cube. So same thing, numerator, denominator, you can cancel, you will get the mole. Okay, so in this example over here, step 1 is to write your balance equation first. 2 sodium hydroxide need 1 H2SO4 to give me 2 sodium sulfate. Sorry, to give me 1 sodium sulfate plus 2 H2O. Okay, anything with the volume and the concentration, you can find the mole first. Okay, so the mole of my sulfuric acid is taking the volume 20 divided by 1000. Why do I do 20 divided by 1000? It's because my volume have to be in dm cube. So 20 divided by 1000, you will convert your cm cube to dm cube. Okay, times 0.5. 0.5 is your mole per dm cube. So times your concentration. Okay, so this will give me 0.01 mole. Answer give you your mole. Okay, so 0.01 mole is the mole of H2SO4. And in this balance equation, next step you have to do is to do the ratio. So 2 NaOH is to 1 H2SO4. Right, so 2 NaOH is to 1 H2SO4. In another words, right, this will be 2 times 0.01 equals to 2 times 0.01. 0.02 moles of NaOH will react with 0.01 mole of H2SO4 in a proper titration. Okay, so there's 0.02 moles of NaOH based on your mole ratio. Okay, so I have 0.02 moles of NaOH. This NaOH is in 25 cm cube. Based on the question, they say that 25 cm cube is needed to neutralize. So 0.02 is in 25 cm cube. So I have to find the concentration of my NaOH. How do I find it again? 0.02 divided by 25 divided by 1000. Okay, 0.02 divided by 25 divided by 1000. Your answer, you get 0.8 mole per dm cube. Some questions there will be unspoken limiting reagent. Okay, when you are able to calculate the mole for all reagents, so this one, the important idea is all reagent. Okay, you have to identify the limiting and use the limiting reagent to do the ratio. Very important. Okay, so in this example, I have 150 grams, the mass of magnesium, and then I have container burns with 50,000 cm cube of oxygen. So this formula over here, this information, if I do the mass over molar mass, you can find the mole. You can find the mole of magnesium. And this information here, 550,000 divided by 24 over here. You can also find the mole. So from this question, it is unwritten. You have to find the limiting reagent. Okay, step 1, same thing, write your balance equation. Okay, step 2, notice that you can count the mole for both your reagent. Okay, so you take 150 mass divide by your molar mass. You get 6.25 moles. And oxygen, you can take 50,000 divide by 24,000. Volume divide by your molar volume because oxygen is gas. Okay, and you get 2.0833 moles. So what does this one means, right? Is if in your balance equation of 2 mg is to 102, 2 mg is to 102. Okay, if I have 6.25 moles of magnesium, this will give me 3.125 moles of oxygen. Okay, it will react with 3.125 moles of oxygen. But in reality, right, I only have 2.083 moles of oxygen. Okay, so what does it mean, right? It means that oxygen is limiting reagent. Okay, because there's not enough oxygen. I should react with 3.125, but I only have 2.0833. Okay, so in another way to see, if I have 2.08 moles of oxygen, it should react with 4.16 moles of magnesium. So instead of having 4.16 moles, it actually has 6.25 moles based on your calculation just now. Okay, so 6.25, this is excess. If this is in excess, then O2 is my limiting reagent. Okay, see, either way, it will help you. Okay, so the next step I have to do is to use the limiting reagent to do your mole ratio. So I have to use the mole of my limiting reagent, which is 2.0833 moles of oxygen will give me 4.1666 moles of magnesium oxide. Why? Because the ratio is 1 oxygen is to 2 magnesium oxide. Okay, so it will give me 4.166 moles of magnesium oxide. Question is asking me what is the mass of magnesium oxide formed. So I will only form 4.166 mole and then apply back your equations, right? So you have mole. Question asks me mass, so apply back this one. I'm trying to find mass. Question I calculated the mole, which is 4.166 molar mass. So you times your molar mass. So take your 4.166 the mole times your molar mass MgO 2416 mass of your magnesium and oxygen. From your periodic table, you get 166.664 grams. That's your mass of magnesium oxide. Keep it to 3SF. 167 grams is your final answer.